Hey y'all, welcome to Unit 3, Lesson 2, which is all about the parts of the periodic table. Um, the first thing that I want to say is make sure that your note sheet this is the front page that says elements on it. It seems I wrote 3.2 on the back side, um, so you'll be very lost if you try to start on this side. So go to the side that says elements, start there. Anyway, all right, moving along. We are going to start talking about elements because that's what the periodic table shows us. It shows us all the elements, all the building blocks that make up everything in the universe. So, first, just a couple of general things. An element is a substance that cannot be broken down further and still retain all the characteristics of that element. So, yes, it can be broken down into protons, neutrons, and electrons, but a proton is just a proton. Like a proton of gold and a proton of chlorine are the same when you just have them separated out into individual protons. But 17 protons with neutrons and electrons all put together is chlorine. And that is an element. Or 79 protons with ever how many electrons and neutrons is gold. Um, and it can't be broken down any further and still be gold. Um, all of the elements have unique chemical and physical properties. We are going to be talking a lot in this unit about what those properties are and how they are related and why the table is put together the way that it is, because they are categorized based on their properties. So everything in the same column have basically the same properties, and also along the rows they're organized in such a way that actually when you understand it, the periodic table makes a lot of sense. um, all of the elements on the periodic table have both a name and a symbol. So the name, like sodium, which whose symbol is Na. A lot of times when the symbol and the name don't match up, it's because they're using the Latin name for the chemical or for the element, instead of the English name that we know. Um, so let's talk about, there's a few different categories of elements on the periodic table. The first are the metals. Metals make up about 75% of the table. The left hand side, as you look at it, when you do your assignment for this lesson, you will be uh, putting everything in their categories, and kind of organizing a periodic table that way. But a few things about metals: they're usually solids. Mercury is the only metal that is liquid at room temperature, but every other metal is a solid. Um, they have some properties like they're shiny, um, they're malleable, which means they can be bent and shaped into different forms, like your pots and pans, or jewelry, or all sorts of different things. Um, or aluminum foil, right? Like it's pounded out into a really thin sheet. They're ductile, which means that they can be drawn into really thin wires, which is why they're used for wires for like electricity, your cell phone charger. If you could look inside, you'd see the thin metal wires um, that conduct electricity, which actually is the next property. They do conduct heat and electricity, so it makes them good for wires, makes them good for pots and pans. They can take the heat from the stove into your food, to heat it up, right? Um, Most metals have very high melting points and boiling points, which is a good thing because you wouldn't want your pot to melt on the stove. You want it to stay a solid to hold onto your food. Um, and they often form positive ions when they're dissolved in water. Um, so that is really important to remember as we go further and talk about chemical reactions. But most metals form positive ions. Remember, those are called cations. Um, there's some examples in your notes. I didn't write them all down. You can put the symbol next to them in your notes on your own time. Just look at a periodic table. But here's a few examples of metals: gold. Uh, that's gold right there. Pretty obvious. Everybody knows what it looks like. Lithium is another metal used in batteries. You've heard of lithium batteries. Sodium is actually a metal. Here's a picture of it. Let me move my face out of the way. But that is sodium. Um, Uranium is a metal. It is a radioactive metal. Uh, Nickel, platinum, calcium. That's nickel right there. Sorry, I didn't switch it quick enough. But before they pound it into nickels, that is what it looks like. Uh, so those are some examples of metals. The next category is nonmetals. They can be found on the right-hand side of the periodic table. Again, your assignment will make that a whole lot clearer to you. Um, some things about nonmetals. They exist as gases, which I spelled wrong, sorry, or solids. Again, there's only one that's liquid at room temperature. That's bromine. Um, Mostly they are gases, a few solids. They're brittle, which means they will break. They won't bend. You can't shape them into different shapes very easily. Um, so they can't be rolled into wires or anything like that. Obviously, the ones that are gases for sure can't. Um, they're poor conductors of electricity, which is why they are used to make like rubber to coat the wires. So when we touch our phone charger, we don't get an electric shock because the electricity doesn't go through the rubber. They don't reflect light. They're not shiny. They're not anything like that. Some of them are diatomic, which means they exist in nature as molecules, like oxygen. Oxygen in nature is two oxygen elements attached to each other. Hydrogen works that way. Nitrogen, you can see some examples in your notes. But they exist as two elements bonded together, not just one. Some examples of nonmetals: sulfur, bromine, oxygen, iodine. Again, you can put all the symbols in your notes for this one. Nitrogen, carbon. I got some pictures too. That's sulfur. Makes that stinky, rotten egg smell. Um, that is iodine right there. And chlorine. It's a gas, a nice yellow gas. Um, anyway, it's very dangerous, so I shouldn't probably say it's nice. So if you flip over to the other side of your notes, there are elements called metalloids. They are basically in between the metals and the nonmetals. They're all solid at room temperature, and they have some properties of metals and some properties of nonmetals. You can see a couple of examples there. That's silicon. It is super shiny, so that does have that property of a metal, but it's not very malleable. It breaks apart pretty easy. Um, and then boron and arsenic, just to kind of look at those. But those are the metalloids, and you will see where they are on the periodic table as you do your assignment. The last category is the noble gases. They are called inert, which means they don't tend to react with other things. Um, so they just basically sit there by themselves. They don't like to play with others at all. Um, all of them are gases at room temperature. Here's a couple examples plus some pictures. This is helium. No, I started with neon. Sorry. This is neon, argon, krypton. So you can see they're in these tubes because they are all gases at room temperature. So here's a good example of the periodic table. The metalloids are kind of this stair-steppy area here right in the middle. Non-metals to the right, metals to the left. Noble gases are this last column right here. Again, I'll move my head. Noble gases. So, as we have said multiple times, scientists use this periodic table to organize information about the elements. And as we go through, you will see just how organized they actually are. It's pretty amazing. A couple of other labels we want to put. Group 1, this first column, Group 1, they're called the alkali metals. They're all very similar to each other. Group 2 here are the alkaline earth metals. Again, very similar to each other. They're, like it says in your notes, really soft metals, pretty reactive. Here along the bottom, elements 95 to 118, these are all synthetic elements. They have not been found in nature anywhere at all. These are man-made in the laboratory, not natural things. So again, they are called the synthetic elements. All right. Thanks for listening. Y'all can move on to your assignment for this lesson. You're going to do some coloring. Yay!